Alright guys, so now we're going to start putting this all together. So the problem is asking us find the zeros and asymptotes of each rational function. So we went over how we can find the vertical asymptotes, we went over how we can find the horizontal asymptotes, okay, and we also went over how to find the zeros. Alright, so let's do a couple problems here and put it all together. So we have this rational function. Remember the first step, as always, you want to try to factor if possible. So look at your numerator, look at your denominator, can you factor here? Well, looking at this, I can definitely factor this. So let's go ahead and factor the numerator here, and you'll get the following. You'll get x. And again, if you want to use the AC method here, you can do that. That's completely fine. Okay. As you get more comfortable, you may not need to use that. All right, so we'll have x plus 3, and then we'll have x minus 2. And this will all be over x. Okay. Well, now that we have it all factored out, we can start determining what the zeros are going to be. And remember, if you want to know what the zeros are going to be, you look at your numerator, okay, and you set it equal to 0. So I have x plus 3. I'll have x plus 3 equal to 0, and I'll also have x minus 2 equal to 0. Well, when I solve both of these, I'll get x equals the following. X equals negative 3, and x equals 2. This tells me, okay, where my zeros are going to be occurring. So my zeros are at x equals negative 3 and x equals 2. So we could say here zeros equal negative 3 and 2. Right, again, this is where it's crossing the x-axis. Okay, so we found the zeros. Now we just got to go ahead and find the asymptotes. So if we want to find the vertical asymptote, we just look at the denominator, right? And remember what I said, your vertical asymptote will always occur at what you have for your domain. Okay, so for example, my domain here, we have x, we're going to set this equal to 0. So we'll have x equal to 0. Let's do interval. Okay. So what this tells me is my domain is going to be all real numbers except when x is equal to 0. Okay, and that exception is going to be where that vertical dashed line or vertical asymptote is occurring. So my vertical asymptote is going to be x equals 0. So let's go ahead and put that in. Vertical asymptote equals, and we said 0. Okay, horizontal okay, so where does my horizontal asymptote occur? Remember, you need to use those 3 rules we talked about. So we have p over x here, so we have the following. We have, again, this is coming right from those rules, p x all over qx. So if the degree of p is higher or greater than the degree of q, what is going to occur here? Well, that's going to tell us that there's going to be no horizontal asymptotes. Again, if the degree of p, looking right here, is greater than the degree of q, which we have here, no horizontal asymptote. Again, that's coming right from those rules we talked about in the previous video. So no, I'm just going to put HA here to abbreviate, no horizontal asymptote. Okay, and this problem would now be done. You could go ahead and graph it. So you already have a lot of information to put on this graph. You could put points on the x-axis at negative 3 and 2, that's your 0. You could draw in your vertical asymptote at 0, vertical dash line. And you also have the horizontal asymptote that is not there, so you don't have to draw that in, right? Okay, so if you wanted to, you can go ahead and graph that. You can make a table of values and you can get the basic shape of that function. All right, you could also use your graphing calculator and use the table feature like we did in the previous problems. However, for these examples, I'm just going to keep it to finding the zeros and asymptotes to save on time. All right. Okay, let's go on to another example. Okay, so we'll have the following here. We have x minus 1 all over x squared. Right. So remember, first step, can you factor either the numerator and denominator? okay? It doesn't look like we can here, all right? It doesn't look like we can. So let's go ahead and start determining some of our key points here. So the zeros, remember we always just look to the numerator and we set it equal to 0. So we have x minus 1 here. We have x minus 1 equal to 0, meaning my 0 is going to occur at x equals 1. Okay, so that's where it's crossing the x-axis. It's crossing at 1. And again, this is a point, so it would be 1 comma 0. All right? Okay, so my zeros, it's crossing the x-axis at 1. And if you want, you can write like this. Okay? But when you say zeros, you're assuming you're talking about the x-axis. All right? So we found the zeros. Let's go ahead and find the asymptotes now. I'm just going to abbreviate here. So VA is for vertical asymptote. So my vertical asymptote, remember, we look at our denominator, okay? And it's going to be your domain, essentially. So if I do x squared equal to 0, this is going to find the domain for me, which is going to be, well, this is just going to be x equals 0, right? So this tells me that my domain is going to be all real numbers except for 0, okay? So it can't be 0. So that tells me what the vertical asymptote is going to be. It's going to be at x equals 0. Okay, so we can put here, vertical asymptote is going to be x equal to 0. Okay, and that's going to be your vertical dashed line. Alright, so we found the zeros, we found the vertical asymptote. Now we just need to find the horizontal asymptote. Alright, so again, we're looking at those rules that we wrote in the previous video where we have P over Q, so we have P of x all over Q of x. So if we look here, the degree of Q is going to be greater than the degree of P. If that's the case, what happens here? Well, that tells you when that occurs that we're going to have a horizontal asymptote at y equals 0. Again, this is coming right from those rules. Okay, so when the degree of Q is greater than the degree of P, which we have going on here, right? Looking at the original. All right, we'll have a horizontal asymptote at 0. Okay? And again, you have enough information now to start building this graph. You have the zeros, which is going to be at x equals 1, or 1 comma 0. You have your vertical asymptote at x equals 1, and you have your horizontal asymptote at y equals 0. Again, you can make a table of values, or you could use table feature in your graphing calculator. All right? Let's do one more example. So we have the following: 2x squared minus 2, okay, all over x squared minus 4. Okay, so first step, as always, when you're dealing with rational functions, can you factor the numerator and denominator? Well, it looks like we can here, right? In the numerator, I can pull out a greatest common factor of 2, so I can do 2, and then I'll have x squared minus 1, right? And if we keep looking at this, we can go further, because this right here is going to be a difference of 2 squares, right? So I can actually rewrite this as x plus 1 and x minus 1. Right? Again, that was a difference of 2 squares. Looking here, same thing, difference of 2 squares. I can write this as x plus 2 and x minus 2. Okay, so make sure that's always your first step, that you go ahead and factor if possible. All right? Okay, let's determine my zeros here. So let's determine the zeros. Okay, so you're going to look to your numerator, right? And you're going to set it equal to 0 to find the zeros. So what I have here right now, I have 2, and then I have x plus 1, and then x minus 1. And we're essentially going to set all of these equal to 0. So 2 equal to 0, x plus 1 equal to 0, x minus 1 equal to 0. Well, if we looked at this, 2 equal to 0, there's nothing to solve for there. So this is nullified, right? Doesn't help us. Here though, we have x plus 1 equal to 0, so when we solve this, we'll get x equals negative 1. Okay, same thing here, when we solve this, we'll get x equals 1. Alright, and that's telling us where it's crossing the x-axis, so we can write this as a point. We'll have negative 1, comma 0, and then we'll have 1, comma 0. Again, that's where it's crossing the x-axis or the zeros. Alright, let's find the vertical asymptotes now. So we have vertical asymptotes. I'm just going to write VA here. Alright, so again, we look to the denominator, and we have x plus 2 and x minus 2. Again, you just want to find your domain here. So if you do x plus 2 equal to 0, and then x minus 2 equal to 0, you want to solve here. We'll get x equals negative 2. We'll get x equals positive 2. Okay, so this tells me that my domain is going to be all real numbers except for negative 2 and 2, meaning that's where the vertical asymptotes are going to be occurring. So we can write here x equals negative 2 and x equals positive 2. That's where the vertical asymptotes are occurring. Horizontal asymptotes, alright, almost done. Again, look to your original rational function, determine what your p is, determine what your q is. So again, we have p of x over q of x, p of x all over q of x. Okay, so my p of x is going to be right here, 2x squared. My q of x is going to be x squared. Alright, notice that they both have the same degree. So go back to your rules. If they both have the same degree, that means it's going to be, alright, division. Alright, and whatever you get there, that will be where your horizontal asymptote is occurring. So my coefficient in front of this x squared is going to be 2. My coefficient in front of this x squared is 1. So 2 divided by 1 is going to be 2, meaning that's where my horizontal asymptote is occurring, at y equals 2. Okay, and this problem is now complete. Again, you have sufficient information to go ahead and start graphing. Okay, and again, you can start building a table, or you could use your graphing calculator and use the table features to pick off some key points so that you could go ahead and graph this properly by hand. All right, and that's it.